So now can you hear me clearly?
Yes, Laushi.
Yes, Laushi, it's clear.
Okay. So
We
let's
can
wait,
hear you clearly.
yeah, let's wait a moment for others. Sorry for the unstable internet. Okay, I will others to enter again in the WeChat group. Okay, so let's continue here. And here we first differentiate this function x power 3 plus 3, and then we times x squared plus 1. So now we can simplify it to, here is 2x, and 2x times x power 3 plus 3, we just times part by part, right? So that equals to 2x power 4 plus 6x, and plus here that also part by part, so equals to 3x power 4 plus 3x power 2. So we can find the final result, that is 5x power 4 plus 3x power 2 plus 6x. So here is the first way to solve this question. Can you understand, guys? And hear me clearly?
Yes.
Okay.
Yes.
Yes, Laushi.
Okay, so here is the first way to solve this question. And the second way, since this function y equals to x power 2 plus 1 times x power 3 plus 3. So we can first times it part by part. So first, x power 2 plus 1 times x power 3 plus 3 equals to x power 2 times x power 3, right? Plus x power 2 times 3. So that is x power 5 plus 3x power 2. And then plus here, 1 times x power 3 and plus 1 times 3. So that is x power 3 plus 3, right? So can you understand this step?
Yes.
Yeah. Okay.
Yes.
So here, that can be dy by dx here. We just differentiate this function, this new function, part by part. So you can see first part that equals to 5x power 4, right? And the second part here, that is 6x, right? And the third part, that is 3x power 2. And finally, the final part, 3 is a constant. So here, that equals to 0. So we can get in the second way, we also have the same result, that dy by dx equals to 5x power 4 plus 6x plus 3x power 2. These two place you can switch. So here are two ways to solve the third question. So any questions? No questions, right? Okay, so here is the solution. Okay, so here is the solution for the third one. So let's move on for the fourth one. Number 4 here, the function is y equals to x times e power x plus x by 4 plus x squared minus cosine 1. And most students made mistakes on this question. So also if we want to find dy by dx, we should differentiate the function part by part. So here are 3 parts, right? So we differentiate part by part. The first, that is dx times ex by dx, right? So from the product rule, that equals to dx by dx times ex and plus dex by dx times x, right? So we can have that equals to, the first here is 1, right? So 1 times ex also equals to ex. And plus here, dex by dx equals to ex itself. We have reviewed just now. So plus x times ex. So here is the result for the first part. And then we calculate the second part here. That is d by dx. Here is x by 4 plus x squared. So that equals to, from the quotient rule, that equals to, here we write 4 plus x squared, right? And then equals to dx by dx times 4 plus x squared and minus d4 plus x squared by dx times x. So we simplify it, equals to here 4 plus x squared, outside square, and here dx by dx equals to 1, so that is 4 plus x squared, and minus here, that is 4 plus x squared. We differentiate, equals to 0 plus 2x. And we don't have to write 0, right? So that is 2x times x. So here, this part, that is 2x squared. So we can have the result that is 4 minus x squared by inside 4 plus x squared outside squared. So the result for the second part is this function. We use the quotient rule. And the last part, d cosine 1 by dx. Here I have a question. D cosine 1 by dx equals to minus sine 1 from the formula. Is it correct, guys?
No, Loshi. No, Loshi.
No, Loshi.
Wait, why?
Because there is no x. It's not x function.
Yeah. Good. So here you should pay attention to this part. This part, many students make mistakes here. Pay attention to here, cosine 1 is a constant, right? It's a value, it's not a function. So d cosine 1 by dx should not be equal to minus sine 1. That should be 0. Yeah, so the final result, we just part 1 sum part 2. So we can get the final result here, that is dy by dx equals to ex plus x times ex, and then plus 4 minus x squared by 4 plus x squared outside square. So here is the result for the fourth one. Here we use the product rule and the quotient rule, and here you should pay attention to this is a value, this is a constant cosine 1, not a function. So the derivative of cosine 1 equals to 0, not minus sine 1. So we come to the last question, number 5. Here, number 5, we have the function that is y equals to x power 3 minus x power 1, x power 2. So here, my question is to find the equation of the tangent line if x equals to minus 1. So first, if you want to solve this question, you should know if I want to, okay, I will write the question to find the equation of the tangent line at the point x equals to minus 1 here. So first you should know that if I want to get the equation of the tangent line, I should know the tangent slope, the slope of this line, right? So how to get the slope? That the geometric meaning of the derivative, that is the slope, the tangent slope at this point. So we first, to get the derivative of this function, that is dy by dx equals to 3x power 2 minus 2x. So this is the first step. We get the derivative of this function. And then you should know if x equals to minus 1. So here, if x equals to minus 1, then the slope equals to 3 times minus 1 squared minus 2 times minus 1. So here we got the slope, the tangent slope at this point, that is 3 plus 2, so equals to 5, right? So that is also the tangent slope at this point, x equals to minus 1. So the last step, I want to write out the equation. So I have the slope. I also want to know the point. And the point I know that is x equals to minus 1, right? And I should know if x equals to minus 1, then y equals to what? So that is y equals to minus 1 power 3 and minus 1 squared, right? So that is minus 1 equals to minus 2. So the point, that is minus 1 minus 2. And the slope, that is 5. So we can have the equation here, that is y minus, here we call it y0, so y minus 2 equals to slope 5 times x minus x0 here, that is minus 1. So we simplify it. Y plus 2 equals to 5 times x plus 1. So we can get that y equals to 5x plus 3. So it is the equation for the tangent line. Okay, so here are the solutions for the homework. 5 questions. Do you have any questions for the homework or the solution?
No, 老师。
No, 老师.
No, 老师.
Okay, so here I will give you one more question here. So guys, please try to calculate one more question here. Please calculate the second x by dx. Do you know second x? Second,
老师。
yeah, equals to 1 by cosine x, right? So please calculate the second x by dx.
I send it to the WeChat group.
Okay, I will check. Yes. So could you please also write the procedure? How to get the result second x times tangent x?
Okay, 老师。
You all don't have procedure and you can get the result directly, right? So you can from the function second x, so can get d second x by dx equals to second x times tangent x. So give me the procedure and I don't want the result, okay? So most of you, I think if you calculate this derivative, so most of you maybe get the result that is sine x by cosine x squared, right? So I think your result should be sine x by cosine x squared. And then maybe you will think to write it by other types. So we can get secant x times tangent x. But not directly give me the result secant x times tangent x.
Laoshi, I sent it to you to the procedure.
Okay.
Can you check?
I have seen it. And also in the final exam, on the answer sheet, I will consider the procedure, not the result. So if you only write the correct result, you will only get only 1 mark or 2 mark for this question, because every step takes 8 marks. So you should write the procedure. Yes. Okay, so let's solve it together here. Since secant x equals to 1 by cosine x, so we know if we want to calculate the derivative of secant x, we of course will use the quotient rule, right? So here that is d secant x by dx equals to d 1 by cosine x by dx. So here we can use the quotient rule here, that is cosine x squared. So here, guys, there is one mistake you often made, that is, here I will write here, cosine x squared and cosine x squared, they are different. They are different. So cosine x squared means cosine x times cosine x, 2 cosine x. So here we want 2 cosine x, right? So cosine x squared, you should write the 2 here, power 2 here, or you can write cosine x outside square. But cosine x squared means cosine, the function is x squared. So they are totally different two functions. So don't make mistakes here. So you should write cosine x squared here, power 2 here, or this type. These two types are correct, okay? And then here, that is the derivative of 1, so that is 0 times cosine x minus 1 times the derivative of cosine x, so here that is minus sine x, right? So we simplify it, equals to 0 times cosine x equals to 0. So we don't write it. And minus here makes a plus. So here, that is sine x by cosine x squared. And that equals to sine x by cosine x times 1 by cosine x. So that equals to secant x times tangent x, because this part is tangent x, right? And 1 by cosine x equals to secant x. So here is the solution for d secant x by dx. And you should remember it as the common formulas here. So I will add this formula to the list of common formulas here. And I will give you a screenshot at last of this class. Here, that is d secant x that equals to secant x times tangent x. And we will later add 2 more formulas here. So here is the formulas and things what we have learned last week. And then we will find that if we differentiate a function, for example, here, if I gave you a function that is y equals to x power 3, then now we know that we can differentiate the function dy by dx that equals to 3x squared, right? And you will find the derivative of the function that is also a function, right? So if the function is also differentiable, so we can do the derivative again on this function. So here we can write y prime equals to 3x squared, right? And then we can differentiate again, that is dy by dx by dx. That means I will calculate the derivative again the second time. So that equals to, you can also write y prime prime or y prime prime, 2 prime here. So that equals to d here, dy by dx is 3x power 2, right? So here, d 3x power 2 by dx. So here that equals to 6x. So we call it second derivative. Here we call it second derivative. Can you understand the second derivative, guys?
Yes, 老师.
Yes, Lord.
So we can have higher order derivatives. You will see y double prime here, that is 6x, right? So we can calculate higher order derivatives here, that is maybe y prime prime prime. That means d 6x by dx, because y prime 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 equals to y double prime prime, right? So we just differentiate the function 6x again, so that equals to 6. That equals to 6. So here, I have a question that if I want to differentiate the function 6 again, then we have the fourth order derivative, right? And that equals to
0.
0, right? So here, we don't write prime, 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 prime here. So from the third, here is the third derivative. So from the fourth, we write like this.
0, 老师.
From the fourth, we have like this.
0.
A 0, right, 0. The result is 0, right? So here means the fourth derivative. And that equals to 0. That equals to 0. So that is the definition of higher order derivatives. We just calculate the derivative of the function again and again. So now I will give you a question here. That is, the function that is y equals to x power 3 minus 3x power 2 plus 2. So I want you to find the first 4 order derivatives. So complete the question here.
Lao Shi, I send it to you.
Also, I also send it to you.
Okay. So in the WeChat group or email or
Widget,
private?
widget.
Okay.
Which group, Laushi?
Okay. Okay, here for the fourth derivative, we don't write 4 prime here. So remember this symbol. Remember this symbol. And I think that is easy. So we just calculate again and again. So first, y prime equals to 3x squared minus 6x. And then y prime prime equals to 6x minus 6. And y prime 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 equals to 6. And the last one, the fourth derivative, that equals to 0. So please think about a question that y equals to x power 2021 plus x 2020 and plus 10. So here I want to calculate y here 2022. That equals to what? Can you answer me directly?
老师 0.
Yeah.
0 老师 0.
Yeah. So here you will find, you will find
minus 2020 plus 2020 minus X.
老师 is calculating in future.
So here, of course, you cannot calculate again and again and again, right? So here you will find that if I want you to find the order of the derivative here is 4, right? The order of the derivative, and the highest power of the function is 3, right? If the order of the derivative is higher than the power of the function, then the result is always 0, right?
Yes. Yes,老师.
Yes, Laushi.
So here, the highest power, that is 2021, right? And I want so here I want to find the order of the derivative, that is 2022. So that must be 0 here, right?
Yes, Laushi.
Yeah. So here I can give you any value, very huge number, but the result, that is always 0. Okay, guys, can you understand?
Yes,
Yeah.
老师, yes.
For this kind of question, you can get the result directly. So here is the definition of the second derivative or higher order derivatives. And then we will learn another rule to calculate the derivative. And this rule is very, very important. So we gave it triple star here. Triple stars here. And in the book, we call it the chain rule. But I think the name of this rule is hard to understand. So later we will have another name. That name is very easy to remember and very easy to use. Just the different name, but the rule is the same. So here we have to figure out one question, that is, we have known that I gave you the function gx. The function gx, that is x power 2 minus 4. And I gave you another function, that is fu, that equals to sine u. So all of us know that d prime, or you can write dg by dx, right? That equals to 2x. And we know that f prime, or you can write df by du here, because the variable here is u, right? Is u. So df by du equals to cosine u, right? But if you have a question that I gave you a function that is f sine x power 2 minus for sine x power to x squared minus 4, then dfx by dx equals to what? So first, we have to know that this function, it consists of two functions, right?
Mama.
Here, sine function is the first function, and then we have another function inside that is x minus 4.
Mama,
So here,
Mama.
okay, so here,
Hey, bro, please mute.
yeah. Okay. Okay, so here I will repeat again. We find that this function f of x that consists of two functions outside, that is sine function, and inside we have that is x squared minus 4. So first, we call this kind of function that the composite function. The composite function. And the composite function means the function consists of more than one functions. So here we can see that is two functions, right? And of course, maybe we will have three functions inside and outside. So we call this kind of function that is composite function. And we can write like this. That is, here, fu equals to sine u, and gx equals to x squared minus 4. So we will find that f of gx equals to sine, we substitute u here, and u here, that is gx, right? So that is x squared minus 4. So this is the symbol of the composite function f of gx, That gx means x squared minus 4, And here is a question we should know, that any two functions can be composed, and our answer is no. Not any two functions can be composed, because here you will see I gave you two functions. The first function, that is fu equals to square root of u. And the second function, that is gx equals to minus 1 by x squared. Or you can write u equals to minus 1 by x squared. So can these two functions, f of u and g of x, composed? Can they composed? No, because here, if I want the composite function here, that means outside is f and inside is g, right? So here you will see for this function gx here, x cannot be 0, right? And for other real numbers of this function, minus 1 by x squared always smaller than 0, right? Minus 1 by x squared always smaller than 0, because here x squared should be larger than 0, and here we have negative, right? So that should be always smaller than 0. But for the function f of u, from the definition, we know if u is under the square root, that u must be larger or equal to 0, right? So we cannot put the function gx inside this function f of u. So here you should remember that any two functions cannot be composed. So here is the first question, and then we want to know how to find the derivative of the composite function. How to find the derivative if y equals to sine x squared minus 4. Then how to find dy by dx? How to find it? So before we give the chain rule, I will give you two examples here. The first one, that is y equals to 3 by 2 times x. And we all know that dy by dx equals to 3 by 2, right? Dy by dx equals to 3 by 2. And this function, y equals to 3 by 2x, it can be a composite function because here we can write like y equals to 1 by 2 u, and u equals to 3x, right? Y equals to 1 by 2 u, and u equals to 3x. So we can get y equals to 1 by 2 times 3x. That is 3 by 2x, right? So here you will see that dy by du equals to 1 by 2, right? And du by dx equals to 3. So you will find one thing, that dy by dx equals to 3 by 2, and dy by du times du by dx also equals to 3 by 2, right? So dy by dx equals to dy by du times du by dx. If you can separate the composite function into two functions, the first function, that is y of u, and the second function, that is u of x. So we will see another function that is y equals to 9x power 4 plus 6x squared plus 1. So for this function, you can also calculate directly that dy by dx equals to what? Equals to, here, that is 36x power 3 plus 12x, right? And this function also can be treated as a composite function, because here we can see that y equals to 3x squared plus 1 outside square, right? So you can write this function as y equals to u squared, and u equals to 3x squared plus 1. So guys, you can calculate by yourself that dy by du equals to 2u, right? And du by dx equals to 6x. Can you follow me, guys?
Yes, Laushi. 12x.
Okay. So here we know that dy by du times du by dx should be 2u times 6x, right? That equals to 12x times u, and u equals to 3x squared plus 1, right? So here that is 3x squared plus 1. So you can also get that dy by du times du by dx equals to 36x power 3 plus 12x. So you can see they have the same result, right?
Laushi, why say her?
Here.
I don't understand this.
U equals to 3x squared plus 1. Here.
Oh,
so,
yeah, Laushi.
Yeah. I just substitute u into here.
Yeah.
Okay. Other questions? No? Okay. So here we can get the chain rule here. That is the chain rule. If we want to calculate the derivative of a composite function, and this composite function may write as f of gx, y equals to f of gx. Then how to calculate this kind of function? We just first let u equals to gx, and we can find that y equals to f of u, right? So dy by dx here, that should, we calculate the derivative from the outside to inside. So that is, the outside is the function f, right? So that is df by here, du. And then times inside, that is here, u equals to g of x, right? So du by dx. So you will get the final result. You will get the final result. Or we can call this chain rule from, we can call it outside-inside rule. So I think that is more easier to understand. Outside, inside rule. So if you see a function that is a composite function, you will first separate it part by part from outside to inside. Then calculate the derivative of each function and then product them. So that is the outside-inside rule or the chain rule. So here we can solve the question above here. That is, we want to solve y equals to sine x squared minus 4 here. So you will see, if I want to solve this question, first we will see that we will let u equals to x squared minus 4. And then y equals to sine u, right? And then dy by dx equals to from outside. So that is cosine u, right? Outside, that is sine, right? So cosine u times inside here, that is 2x. So that equals to 2x times cosine u. And don't forget to substitute u back here. U equals to x squared minus 4. So that equals to 2x cosine x squared minus 4. So here maybe you can add one step, that is dy by dx equals to dy by du times du by dx. And this part, dy by du should be cosine u, right? And du by dx should be 2x here, this part. So we call it from outside inside rule. First, calculate the outside, then inside. So can you understand how I solve this question of the composite function? Guys?
Yeah.
Yes?
Yes, Laushi.
Okay. So
Please repeat again one time.
Okay, I will give you another example here. Another example. This is the first one, the second. Okay, second question here. I want you to find y equals to 2 times 8x minus 1 outside power 3. So if I want to find dy by dx here, first we let, here we can see 8x minus 1 is the inside function, right? So we let u equals to 8x minus 1. So we can get y equals to what? 2u power 3, right? So this step, can you understand, guys?
Yes, Laushi.
Part is, yeah. So I rewrite y equals to 2u power 3, and then dy by dx equals to dy by du times du by dx. Then the outside, that is dy by du here, right? Dy by du equals to 6u squared, right? And then times du by dx, that equals to 8, right? So you can find that equals to 48 u squared. And don't forget to substitute u back here. U is 8x. So that equals to 48 times 8x minus 1 squared. So we solve this question. Can you understand, guys?
Yeah, 老师.
Yeah.
Yes.
Okay. No question, right? Okay. So
Laushi?
Uh-huh.
Please
8 come from?
8 here. Okay. Here,
Laushi, please repeat from the first line.
first line.
Yeah,
Okay.
from the first line.
Okay, here, the function that is y equals to 2 times here, power 3, right? So we can let inside here 8x minus 1, it is also a function, right? Because if I give you the function that is y equals to 2x power 3, you will calculate dy by dx equals to 6x power 2, right? So here we can make it easier like this. So we let u, we give another letter, or you can write t, v, any letter is okay here. So we let u equals to 8x minus 1 here to replace this part. So you will find y equals to 2u power 3 because 8x minus y equals to u. So we separate the function to 2 parts here. So this is the first line. And then from
Lasha, how can you get y equal to 2u power 3?
Check the equation, man.
here is the question. Here's the question. If this part is u, then y equals to 2u power 3, right?
Laoshe,
Okay.
Yes,
Yeah.
So
Laushi.
Laushi, what you are trying to say is that
the last line,
we have
6 u square into 8, where we can find 8.
U squared times
6
8.
u square point into 8.
Yeah. So here that is 48 u squared.
No, Laoshe, here 8, where we can find that?
Because
6
6 times u, 6 times 8. That is 48. And
He
and
and
Yeah,
you
what
square.
he's trying to say. Okay, bro, you have to find the derivative of 8x minus 1, then
Derivative
it
of
will
u.
get 8.
Yeah, here. U equals to 8x minus 1, right? So du by dx here. Du by,
Oh, okay, Laoshe.
yeah,
Okay, Laoshe. It's okay.
that equals to d 8x minus 1 by dx. So that equals to 8. So that equals to 8. So other questions? No more questions? Okay.
Yeah.
So I will give you some exercise so you can practice by yourself to check if you understand. So here I will give you some exercise. First one, that is y equals to 2x plus 1 power 5. The questions are all to find dy by dx. dy here. And number two, that is y equals to sine x power 3. And number three, that is y equals to sine x power 3. So try to solve these 3 questions. The first one is very similar to the example I gave you just now, right? So first try to follow my steps just now and try to solve the first one.
Laushi,
Yeah.
is this a cube? In
The
cube x.
power
Second one,
3.
yeah, the power one is okay.
Power
Okay.
3. power 3. Okay, let's solve the first one and take a break. And after break, we will solve the last two. Okay, the first, that is very similar to the example. So we can let u equals to 2x plus 1, right? And then we have y equals to u power 5, right? So we know dy by dx here equals to dy by du, and then times du by dx. So we first calculate dy by du. So dy by du here equals to 5 times u power 4, right? We use the power rule. And then times this part, du by dx. So u equals to 2x plus 1. So du by dx equals to 2, right? So that equals to 10 times u power 4, and u equals to 2x plus 1. So we substitute u back here. That equals to 10 times 2x plus 1 power 4. So this is the final result of the first question. So can you understand, guys? Do you have any questions?
Yes, Loshi. No, Loshi.
Okay. Okay.
Lashi, I have a question.
Okay.
How can I get 2?
2. Okay.
Yeah,
Here.
yeah.
Because we let u equals to 2x plus 1, right? So du by dx means here d, we substitute u here, that is 2x plus 1 by dx, right? Or you can write 2x plus 1 prime, right? So we should calculate part by part. The first part, 2x prime equals to 2, right? And 1 prime equals to 0. So that equals to 2.
Yeah, Lashi got it.
Okay.
Thank you.
And other questions?
老师 y equals to u power 5.
Why? Because we let 2x plus 1 equals to u here. So we just substitute, replace this part 2x plus 1 to u here. So we can have u equals to u power 5. We just substitute u into the original function to get y equals to u power 5.
Laoshi,
Okay, that's it. Thank you.
how we get 5u power 4?
Oh, dy by du here. Dy by du here, that equals to y here, u power 5, right? So here d u power 5 by du. So that equals to, or you can write u power 5 prime. So that equals to 5u power 5 minus 1. So 5u power 4. That is 5 times u power 4.
Okay, Laoshi.
Okay. And the question,
Good morning, Laoshi.
good morning. Okay, so guys, you will find if you practice more and very skillful, you will find if you want to find dy by dx, y equals to 2x plus 1 power 5. If you want to find the dy by dx, or you can write y prime, you can get the result directly after practicing. Okay, here that is from the outside that is power 5. So you will find 5, 2x plus 1 power 4, because 5 minus 1 here, and time inside prime, and inside prime, that is 2x plus 1 prime. That is 10 times 2x plus 1 power 4. And this part, after practicing very much exercise, you can get the result directly. You don't have to let u be 2x plus 1 and y be u power 5. You can get this directly. But for now, I suggest you to separate the function part by part, and you can get a correct answer. Okay, guys? So we will have a break now, also 15 minutes. So we will be back 35, right?
Yeah,
Okay.
Laoshi.
Okay, take a break.
Laoshi.
Okay.
Okay, have breakfast.
Okay. And now lunch time, Laoshi.
Yes? You don't understand?
Yellow, you understand?
Okay,
Yeah, Laoshi, we understand.
okay. So I always clear just now?
Yeah, Laoshi.
Laoshi, you are always clear, Laoshi.
Okay. So have a break. 要不干脆向他低头，别再苦苦压抑心里的痛。那个爱过算什么？看痛快的等于堕落，你是不是为而活？在街头。到最后，如果我辛辛苦苦是为了什么？满足而归，无所谓。什么自由，我别控制，自作自受自恋。满足而归，无后悔。我最后还是幸福，你又何要不痛痛快快，哭个够，要不干脆向低头，别再苦苦压抑心里的痛。那个爱算什么？看破坏了的与堕落，你是一生不是为而活。在街头，到最后，如果我辛辛苦苦是为了什么？满足而归，无所谓。什么自由，我天空之城，自作自受自恋。满足而归，无后悔。我最后还是幸福，你又何满足而归，无所谓。什么自由，我天空之城，自作自受自恋。满足而归，无后悔。我最后还是幸福，你又何Okay, there is 1 minute for break. Okay, guys, let's back to the class. So I see one student before the break sent the correct answer of the number 2 and number 3 solution. So try to figure it out how to solve number 2 and number 3. And by the way, I'm Miss Zhou in the WeChat group. Okay, and Miss Lee is your teacher for mathematical foundation. So Okay, so let's first solve number 2. Number 2, that is y equals to sine x power 3. So here you can let u equals to sine x and y equals to u power 3. So you can get dy by dx equals to dy by du and times du by dx. So you should calculate part by part. First, dy by du here. So dy by du equals to du power 3 by du. So that equals to 3u squared. So here that is 3u squared and times du by dx. So u equals to sine x. So du by dx equals to cosine x, right? So that equals to 3 times cosine x times u squared, and u equals to sine x, right? So that is sine x squared. So this is the result for the second question. 3 times cosine x times sine x squared. So any question for number 2?
Lasha, please explain
Oh, which part?
from the first line.
From the first.
Second line. 3u is square. This
3
line.
squared. Okay.
Yes, from this line.
Okay, here you can see. I will change the color here. dy by du here. We solve here. dy by du here y equals to u power 3, right? So dy by du, maybe here we write prime, you can see clearly. So here dy by du equals to here u power 3 prime, and u power 3 prime equals to 3 times u power 3 minus 1. So that equals to 3u squared. So this part, 3u squared. And then second part, du by dx, because u equals to sine x, right? So du by dx, that is d sine x by dx. So that is cosine x. So cosine x here. And the last step, we substitute u back, and u equals to sine x, right? So u squared, that is sine x outside square. So we write square here. So we can get the final result, that is 3 cosine x times sine x squared. Can you understand now?
Yes, Lasha.
Okay, other questions? Okay, now more. So we come to the last one, number 3. That is y equals to sine x power 3, right? Remember that equals to sine the function inside, that is x power 3. So here we let u equals to x power 3, and now y equals to sine u, right? So dy by dx here equals to dy by du times du by dx. And the first part, dy by du here. Dy by du equals to d sine u by du. So that equals to cosine u, right? So here, cosine u and times du by dx here. Du by dx, because we let u equals to x power 3, so that equals to dx power 3 by dx. So that equals to 3x power 2, right? So we times 3x power 2. So the last step, we substitute u back. So that equals to 3x squared times cosine u x power 3, x power 3. So this is the final result for question number 3. Any questions? Any questions?
No, 老师。
Okay.
No, Lash, no.
Okay. So I think now I think now you can understand a little bit about the chain rule, right? From the outside to inside. So next, I will give you more exercises. So exercise 4, that is y equals to here x by 5 plus 1 by 5x power 5. And then number 5, that is y equals to second, oh sorry, here, second inside tangent x. So please solve these two questions.
Laushi, I do first one. Send WeChat.
Okay, I'm checking. There is a mistake for the sign. I have circled it. Please check.
Oh yeah, I mistakenly
Yeah.
just give x square.
Yeah. Please be careful. Don't make little mistakes. Okay, let's solve together number 4. First, we let inside be u. So we let u equals to x by 5 plus 1 by 5x. And here, y equals to u power 5, right? So we know dy by dx equals to dy by du times du by dx. So we have the first dy by du. So dy by du equals to u power 5 prime, right? So that equals to 5u power 4. So 5u power 4. And then we times du by dx. And here u equals to x by 5 plus 1 by 5x. And I noticed some students use the quotient rule here. Of course, it is okay, but don't make mistakes here. So if you use quotient rule, it should be written as x squared plus 1 and by 5x, right? So you can use quotient rule, or you can just calculate the derivative part by part, right? So du by dx here just equals to x by 5 prime plus 1 by 5x prime, right? And that equals to here x by 5 prime. 1 by 5 is a constant, so we can take it outside. And x prime equals to 1. So here it is 1 by 5. And plus here, you can also take 1 by 5 outside and then times 1 by x prime. And 1 by x prime means x power minus 1, right? So here, that is, oh, sorry, here is plus. Here's plus. And here, that means 1 by 5 plus 1 by 5. And here that is x power minus 1. So minus 1 times x power minus 2. So we can get here that is 1 by 5, then minus 1 by 5 times 1 by x squared. So we know du by dx here, that equals to 1 by 5 minus 1 by 5 x squared, right? So that equals to, we can take 1 by 5 outside, and that can be cancelled by 5, right? So we have, that is u power 4 times 1 minus 1 by x squared. So we substitute u back here. That equals to x by 5 plus 1 by 5x power 4, and then times 1 by x power 2. So this is the final result of this question. So can you understand, guys?
No, Laoshi, no.
I can't understand from here.
Laoshi, please repeat again.
Okay. Oh, repeat all, right?
Yeah, yeah.
Okay. Okay, here. Okay. Okay. Here. Now I will repeat here again. Okay. Please remove the circle and I will write this part again. Remove the right circle. Who circle here?
Who write the circle?
Yeah. Remove the circle.
Laoshi, we don't know that. Who write the circle?
Maybe Sakodi.
Sakodi.
Maybe. Not sure.
Sakodi.
Oh, okay.
Hey, bro.
Not remove it. Right? Okay.
Maybe he can understand me, Laoshi.
I try later. I will change the color to blue. So here we know first step, right? This step and this step, I think I can skip. You can know, right? And then dy by du, that is also easy. U power 5 prime equals to 5 times u power 4, right? And this part, it is easy. So maybe you will be confused at this part, du by dx. So we write here, u equals to x by 5 plus 1 by 5x. So du by dx, du by dx, that equals to, we calculate the derivative part by part. So that equals to x by 5 prime plus 1 by 5x prime, right? So here you will see x by 5 prime. We separate it again here. X by 5 prime, that equals to here 1 by 5 times x prime, right? And here 1 by 5 is a constant, so you can take it out, equals to 1 by 5 times x prime, right? And x prime equals to 1, because here power is 1, right? So that equals to 1 by 5. So this part equals to 1 by 5. And second part plus 1 by 5x prime. That equals to, here also 1 by 5 is a constant. And then times 1 by x. So you will see 1 by 5 times 1 by x equals to 1 by 5x, right? So here we can also take the constant out. So that equals to 1 by 5, and then 1 by x prime, right? And 1 by 5, 1 by x can be written as x power minus 1 prime. So that equals to here 1 by 5 times minus 1. We use the power rule here, minus 1 times x minus 1 minus 1. So that equals to minus 1 by 5 times x power minus 2. And x power minus 2 can be written as 1 by x squared, right? So that can be written as minus 1 by 5 x squared. So the second part, that is minus 1 by 5 x squared. So we have du by dx equals to 1 by 5 minus 1 by 5 x squared. And we can take the common factor 1 by 5 out. So that equals to 1 by 5 times 1 minus 1 by x squared. So this is the second part, du by dx here. The second part, du by dx. Here, du by dx equals to 5 times 1 minus 1 by x squared, right? And dy by du equals to, 1 by 5. Dy by du equals to 5 u power 4. So here 5 can be cancelled. So we have u power 4 times 1 minus x by x squared. And the last step, we substitute u back. So we have the final result here. Can you understand now? Any questions again for this question?
No.
Don't understand, Yoshi.
Okay. So maybe you guys can help each other to try to figure out how to remove the circle. Okay. Next one.
Laushi, you can also do that.
Maybe I cannot. Because I tap on the screen and there is no reflect.
Maybe if you turn off
Who write the
annotation,
circle? Who write
it
the
will
circle?
remove it.
Okay. Maybe only
I wrote it, but I can't remove it. I don't know why I can't remove it.
so others.
I was sure something was that.
Please.
对。Maybe somebody can try to help him.
Yes,
I'm
I'm
able to
using
try again.
the eraser to clean it, but it's not going. I don't know why.
Because I cannot remove it. Okay.
If it is problem, then we can come back our Zummu account again.
Okay. Try to find.
Restart again.
Okay.
So on math, like Saturn.
Okay, let's move on to the number 5. That is y equals to second inside tangent. So here, yeah, I follow the steps in the dialog box. I mean,
If you close the table, restart again.
yeah. Somebody remove it. Okay, thank you. Okay, now we will find y by dx here. And now, okay, here you will see first we let the inside function tangent x equals to u equals to tangent x, and then we let y equals to second u, right? So now we know if we want to find dy by dx, that equals to dy by du times du by d. It's okay now, it's okay. And then we will calculate part by part, right? The first part, that is dy by du. Here, y equals to second u. So dy by du. Remember the formula at the beginning of the class? We have calculated, right? So,
Second square
yes,
U
second u, the second u by u equals to second u times 10
10
u.
U.
Yeah. And then the second part, that is du by dx. And here, u equals to tangent x. So du by dx equals to second
Second square X.
x squared, right? So we have dy by du times du by dx. That is second u times tangent u, and then times second x squared. And then the last step, we substitute u. And u here equals tangent x. So that equals to second inside tangent x times tangent inside tangent x. And then the last step times second x squared. Here, second x squared. So we have the final result for this question. And pay attention here, the symbol tangent. We often write tangent because that means tangent, the first three letters. Or sometimes in some books, you may see that, right, TG, that also means tangent. These two symbols is okay, but we don't write TANG. So mostly we write TAN, tangent, or TG, means tangent. So pay attention to the symbol. So here is the solution for number 5. Any questions here?
Yes, Laoshi, I'm a bit confused about where you get that sec squared x.
Seconds, for the formula we have calculated last week.
Okay,
Yeah.
Laoshi.
And I have written it at the above of the class. So after I sent you the whiteboard writing, you will find at the first part, you will see the formulas there. So other questions? No questions? Okay, so guys, you should remember the chain rule, and the chain rule means calculate the derivative from outside to inside, from the outside to inside. So that is the chain rule, and we often use during calculating. And then there is another type. There is another type of functions. Okay, I will rewrite here. Okay, there is another type of expression of functions. For example, we all know in the space that x squared plus y squared equals to 1. And in the plane, that means a circle, right? That means a circle. And there is another way to show the equation for the circle. That is, we often write, because we know for the trig functions, there is a formula that is sine x squared plus cosine x squared equals to 1, right? So we often write like x equals to sine t, or we can write cosine t. X equals to cosine t and y equals to sine t. So you will find that x squared plus y squared equals to cosine t squared plus sine t squared equals to 1, right? So these two equations are all the equation for a circle with the radius 1. So here, we call this kind of circle, here you can see, x and y are two functions of the variable t here, right? And t is larger or equal to 0, smaller or equal to 2 pi, right? 2 pi means a circle. So here we call this kind of equations that x and y are functions of the same variable t. This kind of equations, we call it parametric equations. We call it parametric equations. So here is a question that if I give you a function that is shown by the parametric equations, for example here, if I give you the function that is x equals to 1 plus t squared and y equals to t power 3. So how to find the derivative of the function? How to find dy by dx? So for this kind of equations, parametric equations, we usually use the way to solve it. That is, if I want to find dy by dx, and here y is a function of t, and x is also a function of t. So we can do one thing, that we divide dt both up and down. So we can see here that is dy by dt and dx by dt, dx by dt. So here we just divide dt both numerator and denominator. Then we can find here dy by dt means the derivative of y, right? So here you can write like y prime of t. And here dx of dt means the derivative of x with respect to t. So you can write x prime t here. So we know now how to find dy by dx for parametric equations that equals to y prime by x prime. So for this question, you will see if I want to find dy by dx here, we just have to know y prime and x prime. And here we know that x equals to 1 plus t
squared.
Yeah, so x prime t equals to 0 plus 2t, right? So that equals to 2t. And here y equals to t power 3. So y prime t equals to 3t
T
squared, right? So we know that dy by dx equals to 3t squared by 2t. So we can know that equals to 3 by 2t. So here, dy by dx equals to 3 by 2t. So if I want you to find that dy by dx as t equals to pi by 2, so you will find that dy by dx, if t equals to pi by 2, we just substitute pi by 2 into this function, right? So that equals to 3 by 2 times pi by 2. 3 by 2 times pi by 2. That equals to 3 pi by 4. So this is how we solve the derivative for the parametric equations. Can you understand?
Now she'll repeat from the last line, that is t is equal to pi by 2, this line. T is equal to pi by 2, this line, please repeat from again.
So the last step, right?
Yeah.
I want to find the value of the derivative if t equals to pi by 2. And now I know dy by dx equals to, this is a function, right? 3 by 2 times t, right? So here you just substitute t equals to pi by 2 into this function t. So that is 3 by 2 times pi by 2 here, because I want the value at t equals to pi by 2. So that is 3 pi by 4. Substitute the value here. Understand now?
Okay, Lashi, got
Okay.
it.
And other questions? No? Okay, so I will give you an exercise here. Please solve it by yourself. That is the parametric equations, that is x equals to 2t plus 3 and y equals to t squared minus 1, and then please find the value of dy by dx at the point t equals to 6. It is easier than the chain rule, right? So don't make mistakes.
Laushi, can I see the previous example again?
Okay. I will screw up. Is it okay?
Yeah, thank you, Laushi.
Pay attention to the numerator and denominator. Don't mix them. Okay, I see most of you can solve it. So here we can see that the first step, we should know dy by dx. So here we know that dy by dx equals to dy by dt numerator and then dx by dt denominator and then dy by dt here y equals to t squared minus 1. So that equals to 2t. And dx by dt here, x equals to 2t plus 3, right? So we have, that is 2. So we have dy by dx equals to t. And now we want to find the value of dy by dx at the point t equals to 6. So we just substitute t equals to 6 into this function. So dy by dx equals to t. So if t equals to 6, then here the value is 6. The value here, that is 6. So this is the result of this example. Any questions?
Yes, Lashi.
Okay.
How output we got 2.
2 here.
Yeah.
Because x equals to, here, x equals to 2t plus 3, right? So here we want to have dx by dt. That means d 2t plus 3. So we have here, that is the first part, 2t prime means 2, right? And 3 prime means 0. So we have 2 here. Any other questions?
No, Lashi.
Okay, no questions. And then we have solved how to find the derivative of parametric equations. And now we have another question that we want to find the derivative of a special function that we call it here, we call it implicit function here. That is implicit function. What means implicit functions? That means most functions we have seen now that is described by an equation of the form y of f of x, y equals to f of x. For example, most functions we see now, that is, for example, y equals to sine x, or more complicated, y equals to sine x squared minus 4. But we can see they are both the type y equals to f of x, right? So we can use the rules or formulas to calculate, to find the derivative of this kind of function. But if now I give you another function, that is, for example, x power 3 plus y power 3 minus 9xy equals to 0. So how to find dy by dx here? So we can see that is not easy, right? Because it is hard to write this equation to the form y equals to f of x. Or it is hard to put y on the left and x, all the x on the, all the y on the left and all the x on the right. Yes, so we call this kind of functions, that is implicit functions. Implicit functions. So here we gave the way to solve implicit functions. So to find dy by dx here, we just do one thing, that is differentiate the function, this function, on both sides, and then try to find it. What that means here, I will give you an easy example and then we can solve this one. So here, maybe you will find if a function that is y squared equals to x here. So how to find dy by dx? Okay, the first way, a direct way, you can find like this. If x is larger or equal to 0, then y equals to square root of x, right? If x is smaller than 0, then y equals to minus square root of x. So here you will find that you will have, if you want to find dy by dx, so you have to calculate the derivative by y sub 1 and y sub 2, and then to find it. So this is a direct way. But here we can differentiate the equation or the function on both sides. And here with respect to the variable x, here. So the function now, that is x squared y squared equals to x, right? So we can do the following things, that is dy squared by dx equals to dx by dx. This means differentiate the function on both sides with respect to x, right? And then here, don't forget the left part. Y is a function of x, right? Y is a function of x. Or you can think that y equals to f of x. That means y is a function of x, right? So here, dy squared by dx. That means df of x, right? And here you will see one thing, that this part, f of x squared, actually it is a composite function. So that equals to, you can let u equals to f of x here. So that equals to the outside, that is u squared, right? And inside, that is f of x. So that equals to 2u times f prime. So here you can substitute u inside here, that equals to 2 f of x times f prime of x. And we use y to write it, that is 2y times y prime. Okay, I will explain here again. Here, dy squared by dx. And here, y is a function of x. Remember that. Y is a function of x. So y can be written as f of x. To let you know that y is not the dependent variable. So here you should remember y is a function of f of x. So if we want to find the derivative of f of x outside squared, that means it is a composite function. That means u equals to f of x and y equals to u squared, right? So dy squared by dx, that equals to d 2u outside 2u here. Oh, here maybe we cannot use y because here is y. So here you cannot. y here. Maybe you can use another type to represent it. So here, we don't write more letters here. So the outside, that is here, the power 2. So we use the chain rule from the outside to inside. So outside, that is 2u. And inside, that is u prime. So that is f prime here. So we substitute u back. That is 2 times f of x times f prime. And we use y to write 2y times y prime. So the left, that is 2y times y prime. So here you just remember that y is a function of x. So here, if you want to calculate the derivative of y squared, don't forget to times the inside prime, inside function prime, that is y prime. And that equals to here, the right side, that is dx by dx, so 1. So you will find that y prime equals to 1 by 2y, 1 by 2y. So here we got dy by dx here, that is 1 by 2y, 1 by 2y. So for implicit functions, you have to remember this one. This is the important thing, that if you calculate the derivative of the function y, don't forget to times y prime here. So I will give you another example here. Okay, if the implicit function, that is x squared y plus xy squared equals to 6. So dy by dx equals to what? So you should know that we differentiate the function on both sides. So here, that is dx squared y by dx, and then plus dxy squared by dx, and then equals to d6 by dx. Okay, we calculate part by part first, this part. This part, dx squared y by dx. So here, to make it clear, we write prime here, x squared y prime. And we use the product rule, right? So that is x squared prime times y, and plus x squared times y prime, right? Here we use the product rule here. And we know that equals to 2xy plus x squared times y prime. So the first part, we get the result. And the second part, dxy squared by dx equals to xy squared prime. And we also use the product rule, that is x prime times y squared, and plus x times y squared prime. And here we know that x prime equals to 1, right? So here, y squared, and plus x times here, y squared prime equals to it is a composite function. So outside that is 2, right? So 2y. And then times inside. Inside is always y prime. So that is y squared plus 2xy times y prime. And we have finished the left part. And the right part, it is a constant. So it always equals to 0, and that equals to 0. So we have, that is, therefore, here, that is 2xy plus x squared y prime and plus y squared plus 2xy y prime equals to 0. And then we put all the terms with y prime on the left and others on the right. So we will find that is x squared y prime plus 2xy prime equals to minus 2xy minus y squared. And then we can take y prime out. So we will find x squared plus 2xy times y prime equals to minus 2xy minus y squared. So we have the final result, that is y prime equals to minus 2xy plus y squared by x squared plus 2xy. So here, it is a result of this question. So pay attention to here. If you see y squared prime, don't forget that should be 2y times y prime. So if here, that is, for example, y power 5 prime, that should be 5 y power 4 and then times y prime. So don't forget y prime here because y is a function of x. Y is a function of x. So you should also calculate the derivative of y here. So don't forget it. It is actually the chain rule for the composite function. So any questions about this one?
Laushi, it's very difficult. So please repeat one more again, please.
Okay. I will repeat one more.
It's not my cup of tea, I guess.
Actually, only the y prime part, maybe it is hard to understand. But maybe after class, you can see the recording and look at this part.
Laushi, can you zoom out, please?
Okay.
Yes.
Okay. So here, maybe after class, you can with the whiteboard writing and see the recording with this part. You will understand why here we have y prime here. Okay. Okay, I will give you another example and I will explain again. Okay. Here. The example that is here, x plus sine y equals to xy. So try to find dy by dx. Here, y prime means dy by dx, right? So try to find dy by dx or try to find y prime. So here, we differentiate the equation on both sides. So here, I just write prime here. So that is x prime, right? Plus sine y prime and equals to x, y prime, right? And the first part, I think you can understand. X prime, that means 1, right? And plus the second one. The second one here, y equals to f of x. And outside, that is sine, right? So here we use the chain rule here from outside to inside. Then outside, that is cosine y. And times inside, that is always y prime. That is always y prime. So we have sine y prime equals to cosine y times y prime. And then equals to, here we use the product rule. That is x prime times y plus x times y prime, right? So we simplify it. That is 1 plus cosine y times y prime. And then equals to x prime equals to 1. So here y plus x y prime. And we make all the y prime terms on the left and others on the right. So here that is cosine y times y prime minus x times y prime. We change x times y prime from the right to the left and equals to y minus 1 here. So we will find that y prime times cosine y minus x equals to y minus 1. So y prime equals to y minus 1 by cosine y by x. So this is the result for this question. Just here, don't forget y prime, and here don't forget y prime, right? Also, you can write dy by dx here. If you are more familiar with the dy by dx type. So any questions? Or you can understand a little bit more.
Just a little bit low.
Okay. 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 So another question, another example. Another example I will show you. And that is also a common formula to for us to use. And that is to find here. To find y equals to arc tangent x dy by dx. Do you remember we have learned this kind of functions at the first class, and that is the inverse function of tangent x. Remember that? We have learned the first class. So y equals to arc tangent x means x here means x equals to tangent y. So here arc means the inverse function. We have learned the first class. So here these two functions are equivalent. Y equals to arc tangent x also means x equals to tangent y. X equals to tangent y. So if I want to find dy by dx, so we just differentiate the equation on both sides. So here you will see that is dx by dx equals to d tangent y by dx here. And the left part that can be cancelled, so that equals to 1. And here, that equals to, from outside here, tangent, that is the outside, right? So that equals to second y squared, right? We use the formula, and then times inside, right? Times inside, that is y prime, that is y prime. Or you can write y prime here as dy by dx. So we know that dy by dx, that's what we want here. So dy by dx equals to 1 by second y squared, right? I just put this part on the left. So we have dy by dx equals to 1 by second y squared. And for second function and tangent function, there is a formula, there is an equation that is second, if I use x or I use t here, second t squared equals to 1 plus tangent t squared. You can use the sine function and the cosine function to check this equation. So here you can change it to 1 by 1 plus tangent t, tangent y here, square. And tangent y, that is x here. So that is 1 by 1 plus x squared. So it is a very common formula to calculate derivative. That is the arctangent function, arctangent x prime equals to 1 by 1 plus x squared. So this is also a common formula for us to remember that. So I will add it at the beginning of the class. So I think, and I know this part is a little bit hard, right? So if
Yes, Lashi.
I know.
So hard.
It is not little bit hard, Laushi.
A little bit.
It's like Himalaya mountain.
Okay. Okay. So over my head, right? So you can you can see the recording.
Rajiv on the top of the Himalaya mountain.
Okay, so you can see the.
I am under the Himalaya mountain. I am feeling pressure like that.
Okay, so you can see the recording, and I will give you more explanation in the whiteboard and send it to you guys. And you can understand a little bit more. But this part, I think the hard part to understand may be the y prime part, right? And the y prime part, that actually means a composite function. So we just use the chain rule to calculate this part. So for this part, you will think it more and try to understand this part. And others, I think the chain rule and the parametric equations, that part is not hard, right? So I think you can focus on the implicit functions this week. So try to understand it. And if you have any questions about the implicit function or how to calculate the derivative of the implicit function, you can contact me and talk with me private in the WeChat. So you can tell me your doubt and I can try to explain it for you. Okay, guys?
Okay, 老师。
Okay, 老师。
Got it.
老师。
And since this part is a little bit hard, so my homework this week is just to see the recordings and try to understand. First, you must understand the chain rule and parametric equations, okay? You
Okay,
must
老师。
understand that. And second, try to understand how to solve the questions about implicit functions. Okay, and this is the homework. No writing, but thinking. Okay.
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 Okay, 老师。
Okay, 老师。
We have, 老师, our homework is we have to practice more and more to get and to understand the math. Like
Yeah.
that, am I right?
Yeah. So I will give you the exercise from the book in the WeChat group. You can choose some to take exercises to practice. But you
Okay,
don't have to send it as a homework. But if you want to know if you did correct, you can contact me and send your procedure to me, and I can check for you. Okay, guys?
Okay, 老师，谢谢老师。
You're welcome. So that is all for today's class. So see you next week, guys.
Yeah, 老师。we are
Okay,
fine.
老师。
再见，老师。
再见，老师。
Well.
谢谢老师，拜拜。
再见，老师。
Okay, so I will end the meeting.
老师。
要老师 will